Hello everyone, today I'm going to show you how to read logarithmic scale on an example of a design spectrum. Okay, so I'm going to use the example that is given on the Unit 5's exercises. Okay, and it's the figure 6. Okay, so I'll just calculate one value, which is velocity. So it's the same as displacement and acceleration, same method. Okay, so to start with, we need to know the natural frequency of the system so that we locate this natural frequency in the graph and then we start plotting the rest. And other thing that we need to know is this equation. It is logarithmic value that we are after. Y is that value, the smallest value that our x value is in between. For example, if our x value is in between 0.1 and 1, that it means y value is 0.1. So if our x value is in between these two values, 0.1 and 0.01, then our y value will be smallest value, which is 0.01. L, small l and capital L is found with our ruler, okay? And I'm going to show you how to find it. So first of all, we know that our frequency is 0.92. So I just locate it randomly, okay? I say this is 0.92 point. And from here, the smallest value up to this point is small l. And the all distance from 0.1 to 1 is capital L. So I'm going to measure it, okay? And I'm going to use these rulers, which are already in here. So here we go. Oops, yes. So first of all, we said the whole gap is capital L. In this case, it is 4 centimeter, okay? So let's just write down what we need. So we know now we know x value, it is 0.92 on this scale. Okay, so it's going to be log 0.92 minus log the smaller value, this 0.92 in between is 0.1, which is equal to, we don't know L. This was a random assignment. We are going to find out L exactly now, over 4 centimeter. Okay, now we can find out L from here. Let's just use calculator. So what we need to do is, let's just reorganize this. Let me just delete this thing. So it's going to be, come on, yeah, mode. So it's going to be log 0.92 over 0.1 is equal to L over 4. So I'll just multiply this value with 4 and it's going to give me L. Okay, let's just do it in here. So it is 4 times, and it works like this, guys. 0.1, 0.1 parentheses double close and log here. 4 times log this value is equal to 3.85. Okay, so the L means 3.85 centimeter. Okay, now I will find out where this exactly is. Okay, so I'll just move it away. So let me just delete this thing now. Let's now find out. So it should be 3.85. Okay, so I'll locate it here. I'll come closer so we can see everything clearly. So here, so it is 3.85. So 3.5, 6, 7, 8, 9. So it's in between here. So our value should be mod on. Oops, it should be somewhere here. Okay, so it cannot be very sensitive because you are measuring with your eyes, so there can be some errors. So it doesn't have to be like perfectly correct value. Okay, so for example, you can see this 4 centimeters or 4.05, 4.02. It depends on your sensitive reading. Okay, so I'm just reading this roughly right now. And in the exam, you won't have too much time, so you can just put ruler. So this is 4 centimeter, good, and 3.8 is here, good, and I'm going to continue. Okay, so let's just put it away, and my ruler. Now I will use this thing to draw a perpendicular line from this point. Now I found out this point from here to my spectra. Okay, my design spectra. Here you go. So I'll just draw one line up there. Let's use another color, a thin red color. Here you go. Something like this. Very close, but no, it's fine. Because this part is already like vertical. So even if you plot it in here, your velocity will be same because this line is vertical to this part. But if you are calculating other displacement and the acceleration, you should be more careful. So I'll just now rotate this to 0 degrees. And yeah, by the way, here. So our line will be from here to here. Okay, so let's just close this ruler now. Now we can find out our velocity. Okay, so first of all, let's just note down what these things are. Please don't. Come on. Here. So the whole distance is again L, and from here to here, the smaller value. Yes, this is small l. Okay, so I'm going to measure L, this L, and I don't know the logarithmic value of this point. I'm going to calculate it with using this equation. Okay, so let's calculate velocity now. Pseudo velocity. So first of all, I need to find out small l and capital L. Okay, so I zoom in here. I put this closer. So our capital L looks like it is 4.1 centimeter. Okay, this is 4.1 centimeter. And let's find out this one. And this one looks like this is 3.6 centimeter. Yeah, 3.65, 3.6. Okay, so our L is, I'll say 3.65 centimeter. Okay, now let's go to this equation. Logarithmic v, we are looking for velocity. We don't know this one. Minus log 0.1. It is this value 0.1 because it's this v value is in between 1 and 0.1, and we are taking the smallest value. So it's going to be 0.1, and this is going to be equal to L over capital L, 3.65 over 4.1. Okay, so let's calculate this. Log v over 0.1 will be equal to 3.65 over 4.1. So there's 10 here. We're going to just send it here. So it's going to be something like this. V is equal to 0.1 times 10 over 3.65 over 4.1. Okay, so let's solve this and see what happens. So 0.1 times 10, it's gonna be power in parentheses 3.65 over 4.1. Let's close the bracket, enter, and V is equal to, what did you find in here? 776. So the unit is meter per second. So RV is equal to 7.776 meter per second. And in the handouts, I think the value was, let me see. Yeah, I think in last year they found 0.75 meter per second, which is quite accurate. So these differences will happen because of we are reading ruler, we are reading these values with ruler. So it depends on the human eye. We can see different values. Okay, so this was last year's. Let's just take a look at it. Copy. Let's paste it in here. Okay, so here we found the location of this frequency exactly, and then based on this frequency we find out the point for velocity, and then with this point we can measure L and capital L with our ruler, and then we can put these values into our equation, and then we can find out V. And if you from here, if you draw the perpendicular line onto this part, you are going to find out displacements, and if it is on this line, you are going to find out the accelerations. Okay, I hope it's going to be helpful for you. So if you have any other questions, please do tell me. Bye bye.